collaboration with NASA and HeroX, developed a challenge called NASA Mars XR, in which they asked students around the world to build tools and equipment in VR so they can train when they go to missions in the future. So these 8 students, to say that they are artists is not enough. They are really explorers, designers, and pioneers in the VR world. The first part depended on us writing down the scenarios that astronauts could face. 4,000 applicants around the world, and we scored 13 out of those, and we did really well. For the second one, they were not part of it. My role was mostly to rebuild the scenarios in a more exciting way, think of what assets we could use, and I just sketched them. That was basically it. And the artists would put the whole, develop them completely, put their own inspiration, and it turned out really well.
I was a team member for the ArtSciLab collaborative project with the NASA XR Mars Challenge for the summer of 2023. I was brought in for my work with 3D, Unreal, texture designer. It was all I had at the moment. So that's where I was at. I pushed forward with the creation of assets, designing assets, implementing assets into the game. I tried a little bit of blueprints for Unreal. So I do have some experience there, and that was all learned and enjoyed while creating assets for this project.
Hi, my name is Andrew Duarte. I'm an A-Tech senior. I graduate spring 2024. My passion is animation and games, and I focus on animation and programming. I was looking for an opportunity to use my artistic ability and my knowledge of programming and apply it into something that relates to science. And conveniently, I ran into the Discord server of the Animation Guild, and I found an opportunity to work in Mars, in the Mars XR project. And I just offered to help.
I'm Chris Gauthier. I was a modeler and texture artist for the NASA XOS project. I worked on scenarios 1 and 2. I modeled the launcher and the plants and the gems and the dirt mounds.
My first asset that I put a lot of time and work in was the glider. That was the first challenge, was having a glider zoom through Mars and it'd get like materials and it'd get broken and all of these questions. I went through the most iterative designs with not only the shape of the glider, but the colors, the texture. I kept on going back and forth on what I wanted to add, what I wanted to remove, and a lot of it did get cut, but it still ended up being one of the most important pieces, as it was like the focal point for an entire scenario. We submitted 4 scenarios, and the glider was by itself a singular scenario.
Yes. So the main troublesome asset was the glider, mostly because it was my first time working with networking in a project. But we got it to work by using the level script that basically prioritized the possession of the glider as soon as it launched from the cocoon launcher. And the problem was getting it to possess back to the player and then repossess, just going back and forth. That was the problem. But we got it. We had something work just by getting it to prioritize the possession of the glider.
So I made the launcher as a machine that would basically launch the glider that would be gathering samples for the surface of Mars. So the launcher is basically, we modeled it a lot off of the startup zipline launcher, or a launcher that was developed by startup zipline for delivering medicines in Africa. So they had developed this contraption where the drone is like on this plane and it gets just pulled by this cord along the plane and it just zips right off into the air. So scenario 1 is the one where I did the launcher. That basically involved sending a drone out to collect samples and then the drone coming back, and the drone had to land in a certain way. I had to be caught in this net. And
so it is an automated rover. Its design is based off of like previous rovers that were sent to Mars, but kind of more bigger to where it's like a semi-truck, or just like a truck to where where the astronauts can like step in and they can be like moved from point A to point B, or they can deliver many objects or heavy objects and stuff.
The next scenario was the 3D printing of a habitat. We used to our advantage the realization that Martian gravity is lower than Earth. It's about like 2/3, about a third. It's really not that heavy, so heavy machinery utilizing advancements that would happen in 3D printing of the world. So the materials to actually 3D print something would be lighter, can be moved, transported very easily. The heaviest aspect of it would be the filament truck, a literal truck that would follow the person, where it would mix Martian terrain with chemicals and other products to create a solid radiation resistant material that could be utilized for a shelter, and also a crane, one that would go up and be the X, Y, and Z pivot for the 3D. So all of it was working in tandem.
There's like the actual mini 3D printer, unlike the big printer. The mini printer is just for printing out, per se, like metal supplies, any materials that we need to help fix some things, or probably like add on to some stuff for our mission.
One of the aspects that I didn't realize until later in the project is how radioactive Mars is. Mars does not have a solar shield equivalent to the magnetic shield of the Earth has. So cosmic radiation is 100 times what it is on Earth. Now, this is horrible. If you were a person on Mars, you would most likely die of cancer. That's why any habitats that were to be designed could not include any windows, any light fixtures from the outside, and it would have to have thick walls to protect people, as Martian rocks were basically the only thing readily available to save someone. The second version of the habitat added a double door, so an airlock where people can at least drop off their thing, airtight lock, and then fresh oxygen could be implemented so they would have the ability to walk around. Again, it's a very small space because the 3D printer itself is rather small. That's the bad thing about 3D printers. They need to become exponentially bigger if you want to build exponentially larger buildings. So this would be a first trip to Mars, and we're not building mansions, we're building actual rooms.
So the plant is basically, it's used more as like a symbol than an actual object that needs to be interacted with. But it's used basically to indicate that you have successfully created this 3D printed building that you need to put plants in, to grow plants in. So this is a plant that you put in at the very end that's like in a little container, a little glass container with oxygen and everything. It has a little green light to indicate that the plant's healthy, and it's something that the person doing the simulation, they just pick it up and put it in the soil at the end of the scenario.
Yeah, I made a robotic dog. Well, we're gonna call it the robot mule, because one, not only does it can carry people around him, it also has a department within it too, where it carries some tools and other things necessary for maybe a mission or.
I only created a cocoon.
Do you know how you got that idea of a cocoon?
The big idea was that we needed to make something foreign, something that didn't look like it belonged from Earth. And this is also, credit goes to Professor Roger Molina. He suggested that we should make it something foreign. And what better than to make it look like an egg? Essentially, the idea is that astronauts are looking for a lost container. And within this period of time, they have to try and find it. So they call a cocoon that's in space, it gets launched, and the aerodynamic shape of the cocoon allows it to enter without any problem, and it lands. And once it lands, the astronaut goes to the cocoon, and they use Bluetooth technology to open it. There's a launcher and a glider inside, and once they open it, they just point the launcher to where they need to. In this case, it's going to be east, because that's where the cocoon is located at. And they shoot it, and it shoots the glider. The glider is remote controlled. They use a tablet, and they just fly the glider around, look for the container, and once they scan the container, it'll show XYZ coordinates in the tablet. And as soon as it scans it, they fly back the glider to a tower net that's supposed to catch it, and that's it. They go retrieve the container and then go back to base.
The second asset that I completed was of a tablet. The tablet was to be utilized by the user in the challenge for them to actually move and work with the glider. So they would operate the glider by a tablet, and it would move around, it would zoom around. It was really cool. We went back and forth on ideating UI, and unfortunately that was one of the weak points on our team, is that we didn't have like a dedicated UI person specifically for the project. Hopefully next year we can get that better, but it was still just a whole lot of fun just to get that off the road.
So scenario 2 is where you're basically going into a cave. Well, it starts out that you're using this machine that's laying piping down, and while you're working on that pipe discovers a precious mineral, and you look at that mineral and you find a trail of them, and it leads you to a cave where you find a whole bunch of these gems that are hidden in the cave.
The name of the drill dozer, I've been teasing and saying that I quite literally stole the idea. It's true. It's because there's a game I've been playing, Deep Rock Galactic, where one of the objectives is you have to push a drill dozer, and it is a bulldozer drill hybrid. And what the focal point of this scenario is to pipe water from one location to another. Instead of it being just a physical tube lying on the floor, it'd be actually breached underneath the surface of Mars. So it'd be a zipper effect. The Martian terrain would be open, piping would go in, and it would just be layered on top of with the remainder of the sediment of the Martian terrain. It's such a crazy design that I basically implemented the highlights of it into a distinct silhouette, where the front of it looked like a Jeep, but it had a roll of piping on top. There were antenna bits. It basically had a stack for a computer to sit on top of it, tank treads, decals, and it would also have like a monolith of a bit. It wasn't a singular like hook. This was a literal obelisk that it was punching into the Martian terrain. It's so crazy. It's so cool, and I'm thankful that it was able to look the way it is.
For the gems, they weren't really modeled off of any one particular real gem. We just knew that there had to be like a precious mineral that had to be hidden in the cave, and so I just came up with some shapes that I thought looked interesting, that looked like gems, and gave them kind of a reddish color, and just tried to make them look a little dirty, look like they had been in the ground for a little while, and just scattered them throughout the cave.
This crane was specifically for a scenario, which is for a mining operation, where we parked the rover to near like a cave, and the crane would either help us make a trolley system sort of or a pulley system to where we can deliver minerals back and forth from point A to point B within outside of the cave and inside of the cave. And it can also be able to help carry stuff as well, or pick up items that we come across heavier than normal.
Yes, I worked on the interaction systems that they use for the cocoon. Everything from the cocoon, such as the cocoon, the launcher, and then the glider, they're all in the same blueprint. The player goes up to it, there's a collision box, and as soon as they collide, they have the option to interact. That's the only button that they can press, and then it opens up the cocoon, plays an animation of the cocoon opening, and there's the launcher, and it just adjusts itself, and they use the controls to point what direction it's going to shoot the glider from. And the glider is another blueprint system, but we can talk about that afterwards.
If you had the chance to work further with this NASA, would you do it?
I would. I think it was a fun and worthwhile project. I think there are definitely ways that I could have improved on my models, especially having a better idea of what was needed, both by the scenario and by the competition. That was kind of the process of me figuring that out as I was going along. So I think it definitely would have been good to, if I did it again, try to have a better understanding of that, and I'd have been able to make some better models, I think.
Definitely. We as a team, the door is still open. NASA is still requesting for the development of VR assets and equipments, tools, and there's not many people out there that has these skills. And UTD is a great place to find them. Through this video, we hopefully can reach out to new artists.
And if NASA keeps getting this, I mean, it can go up. I mean, $75K for the pot this year. It can go $100K, $250,000 next year. We're fighting against individuals. We're fighting against studios. We're fighting against professionals and just avid enjoyers. It's so much fun to imagine a good project like this. Not only does it add so much in terms of like team building and portfolio building, but it was just great networking as well to meet all of these people. We got to interact with the VR lab that just got built up over the last year. We got to talk with 3D Studio. We got to talk here in an ArtSciLab, Games Media Lab, and it was just fun to connect and interact with everyone, because often, especially after the pandemic, so often there's like team building is just difficult for younger audiences to truly interact with. That's my 15-hour speech. Thank you for coming to my TED Talk. The drinks aren't free. Good night.